Find the envelope of x by a plus y by b equals 1, where a and b are parameters, connected by the relation a raised to m into b raised to n equals c raised to m plus n, where c is just a constant. In order to find out envelope, we will eliminate parameter a and b between the two equations given. Let us call the given equation x by a plus y by b equals 1, whose envelope we wish to find as equation 1. Let us call the relation connecting parameters a and b as equation 3. By equation 3, it is clear that parameter a can be considered as a function on parameter b, or parameter b can be considered as a function on parameter a. You can rewrite 3 as b raised to n equals c raised to m plus n divided by a raised to m, where c is just a constant. With this representation of equation 3, it is clear that parameter b depends on parameter a. When you partially differentiate equation 1 with respect to parameter b, treating x and y as constants, we will get the equation minus x by a square minus y by b square multiplied to db by dA equals 0. We have partial derivative of 1 by b with respect to parameter a is obtained as negative 1 by b square multiplied to db by dA. It's enough to consider total derivative db by dA because b depends only on single independent variable a, since we have c is only a constant. Now we will partially differentiate equation 3 with respect to parameter a. We will have to make use of product rule of differentiation when you take derivative of LHS. First function a raised to m into derivative of b raised to n plus derivative of first function a raised to m plus b raised to n equals 0, because derivative of c raised to n plus n with respect to a equals 0. We have derivative of b raised to n with respect to a is obtained as n times b raised to n minus 1 multiplied to db by dA. Derivative of first function a raised to m will be m times a raised to m minus 1. Thus we will arrive at this equation when you partially differentiate equation 3 with respect to parameter a. From this equation, we can find out an expression for dB by dA. You will take the second term of the equation b raised to n m a raised to m minus 1 to the RHS. Then we have dB by dA equals negative m a raised to m minus 1 multiplied to b raised to n upon a raised to m into n into b raised to n minus 1. We have b raised to n upon b raised to n minus 1 becomes b raised to n minus n plus 1, which equals b. We have a raised to m minus 1 upon a raised to m equals 1 by a raised to m minus m plus m, which equals 1 by a. We just take b raised to n minus 1 to numerator and a raised to m minus 1 to denominator and apply the exponential law. Thus we have dB by dA equals minus mb divided by na. Let us call this as equation 4. We will use 4 in equation 2. That is, in equation 2, we can replace dB by dA as minus mb divided by na. Thus we arrive at this equation, and it can be rewritten as minus x by a square equals negative of ym divided by bna, which is same as x by am equals y by bn. We can cancel a from both denominators and we will get this equation. This equation can be rewritten as x by a divided by m equals y by b divided by n. Since we have by componendo dividendo rule, whenever two ratios a by b equals c by d, we have a plus c divided by b plus d will also be equal to each of these ratios. By this general componendo dividendo rule, we have these two ratios will be equal to x by a plus y by b divided by m plus n. By equation 1, we have x by a plus y by b equals 1, and thus this numerator can be replaced by 1. Thus we have x by am equals 1 by m plus n and y by bn also equals 1 by m plus n. From these two relations, we will find out expressions for parameter a and b. We have a equals m plus n multiplied to x divided by m, and b equals m plus n multiplied to y divided by n. We just take a as numerator to RHS and bring all other terms to the LHS. Similarly, we bring b as numerator to RHS and all other terms to LHS, and we arrive at equation 5. Since we wish to find out envelope by eliminating parameters a and b, we will give the relations obtained as equation in equation 3. Equation 3, which is the relation connecting parameters a and b, is rewritten in this way, giving expressions of a and b, which follows from equation 5. Here, you can rewrite the LHS as x raised to n into y raised to n multiplied to m plus n the whole raised to m plus n divided by m raised to m into n raised to n. We have by exponential law m plus n the whole raised to m multiplied to m plus n the whole raised to n equals m plus n the whole raised to m plus n. When you take terms independent of x and y from LHS to RHS, this equation can be rewritten as x raised to m into y raised to n equals c by m plus n the whole raised to m plus n multiplied to m raised to n into n raised to n, which is the required envelope independent of parameters a and b.